Hi, welcome back to this chapter. We're still in chapter 4, chemical bonding, and this is the last video under the subtopic of Lewis structure. This last video, we're going to discuss about resonance. As we know, sometimes we can draw more than one Lewis structure for a molecule. But however, in the previous video, even though we draw more than one Lewis structure, but they have different formal charge. But today's case is going to have same formal charge. So if you can draw more than one Lewis structure, but each of the atom has a similar formal charge, then we will consider resonance concept is happening. So for example, here, the double bond is between carbon and oxygen. This one, second structure, also the carbon double bond and oxygen. Only the position is different. So that's why we say that both structures look same, but actually their position of the double bond are different. So we still consider these two as different structure. So when both different structure able to draw, and then every Lewis structure that you draw, for example, this one have 3 zero formal charge and 1 negative one, which the negative one is belongs to oxygen. The second Lewis structure also the same. There is 3 formal charge with the 0, and then 1 formal charge with negative 1, and also belongs to negative 1. So in this case, we consider they are resonance structure. Okay, so again, conclude again. Resonance structure means it can show 2 or more Lewis structure, only differ from the distribution of electron, and where here we emphasize on the position of multiple bond. And then the arrow, once you see this arrow, you know that the molecules or the structure are showing that they are resonance structure. Okay, let's look at one example of the resonance structure, and here they're showing SO₂. So consider that you already know how to draw the Lewis structure for SO₂. So this is the structure. So when we look at so-called structure A and also structure B, they look similar, but actually they are different from the position of the double bond. You can see at structure A, the double bond is at the left side, while for the structure B, the double bond is at the right side. And then at the same time, there is 1 single bond, 1 double bond, and sulfur has 1 lone pair electron. So in this case, they are resonance structure. So in between them, we use this arrow to represent it. So next one, we look at another example, which is SO₃. So again, when you look at here, also consists of 2 single bond, 1 double bond, 2 single bond, 1 double bond, 2 single bond, 1 double bond. This time, let's say, you can see sulfur has no lone pair electron. And then changing it, we just focus on the double bond at the bottom right, bottom left, and then at the center. So again, all these 3 structures are equivalent, that means they are similar, and they are known as resonance structure. If we blend these 3 structures together, we are going to produce a structure named as resonance hybrid, at where the bond is not single or double bond. They are intermediate of single and double bond. Okay, so this one generally resonance hybrid will known as like average of all resonance structure. Okay, so as we know the meaning of hybrid, let's say hybrid car means that the car can be used petrol or also can use electricity. Okay, so now means that we mix these three together. Now the double bond can be at any position. So that's why they are actually moving the double bond from part A, B, C, and then go back to A, B, C. So the double bond is always moving. Okay, so that's why we will not draw a solid single bond or a solid double bond in between these two atoms. We only will show intermediate of single and double bond. Now, let's continue with the summary of resonance hybrid and resonance structure. As from the word hybrid, just now we already mentioned, it is actually average for all the Lewis structure. While the resonance structure, you have to show two or more with the same number of valence electron and different distribution of electron. And where actually from the structure, normally we focus on the position of multiple bond. So again, this is another compound which can show resonance structure as well. This is ozone O3, where you can see if the bond is intermediate between single and double, we know this is resonance hybrid. If the bond is very clear, we can see double, single, single, double, and basically with this arrow, the structure 1 and 2 are considered as resonance structures. Let's come for a quick check. Which of the following is represent Lewis resonance structure? So yes, A is resonance structure because the bond single and double is very solid. B is not resonance structure because the single and double bond is not solid, but this one is show intermediate of single and double bond. So we consider D as the resonance hybrid. Okay, so I hope you can differentiate between the resonance structure and also the resonance hybrid. There are a few common molecules or ions that is able to form resonance structure, or they are showing the resonance property. O3, NO3 negative, CO3 2 negative, SO2, SO3, NCO negative, NO2 negative, NO2, PO₄ negative, POCl3, SO₄ negative, COCl2, and the last one, NOCl. Okay, just a reminder again, this is just part of the common molecules, and then from all these molecules, actually we can notice that most of the compound that can show resonance structure consists of oxygen. So this is just a very general and quick summary, but not all, just majority of the resonance structure may consist of oxygen atom. Okay, now we are going to continue with tutorial question number 8. We need to draw the Lewis structure for, resonance structure for SO3. So actually, before you can draw the resonance structure for the SO3, we actually start from the method that we draw the Lewis structure. Okay, after we draw the Lewis structure, and then based on your understanding, then you're able to identify whether the compound able to show resonance property or not. So step number 1, we are going to determine the number of valence electron, total number of valence electrons. Sulfur has 6 electrons, oxygen also has 6. So in this case, we have 4 atoms with 6 valence electrons, so total is 24 electrons. And obviously, this one, the sulfur is the central atom, step 2. So then we are going to draw the skeletal structure, step number 3. Step number 4, we are going to distribute the electron to each of the terminal atom until all that. So now we have 3 terminal atoms, And then each terminal atom achieves octet, so it means that altogether we have 24 electrons. So total now, after we minus this 124, there is no extra electron. Then next we are going to check is the central atom octet, step number 5. Yeah, not octet. So what we are going to do, we will going to move one pair of electrons from any oxygen to form double bond. Okay, so after we form this double bond, then we will notice the double bond not only can be at the bottom right, but the double bond may also form at the central top or either bottom left. So even though I already changed the position of the double bond, but the total formal charge and also the formal charge for oxygen single bond still always -1, no matter it is in structure, first structure, second or third structure. And the sulfur always have the formal charge of +2. Same case happen to the oxygen. Double bond with sulfur always have the formal charge of 0. So at this case, we can say that SO3 able to form resonance structure or resonance properties. So after we change the position of the double bond, then don't forget you have to place this arrow to show that they are resonance structure. Next question is about NO3 negative. Again, step number 1. Nitrogen 5, oxygen 6 electron, valence electron times 3. -1 means gain 1 electron. Total 24 electron. Nitrogen is the central. Draw the center structure. And then number 4, assign the electron to the terminal atom until octet. So then we are going to check any extra electron. 3 terminal atom with 8 electron, 24, so no extra electron. Then we are going to check the central atom. Again, central atom is not octet yet, so we are going to move one pair of electron from any oxygen and then to form double bond. So similar case happen, the double bond can be changed the position from the bottom to the right and then to the left here. So again, after we change the position, add on this arrow, then we are able to prove that NO3 negative also show the resonance properties. Last question in tutorial for resonance structure is PO₄ negative. Again, step number 1, phosphorus has 5 valence electron, oxygen has 6 valence electron, and then gain 3 electron. So total is 32 electron. Phosphorus is the central atom. And then oxygen is the terminal atom. Assign electron until octet. So 4 terminal atom, each terminal atom has 8 electrons. 4 times 8 is 32. So total is 32 lah. And then no extra electron. But then when we calculate the formal charge for oxygen, as we already calculate quite a few times, so we roughly already have the idea. Oxygen single bond is -1. So, and then phosphorus has 5 valence electron, -4, so it's +1. When we look at this structure, we will notice that this supposedly is not a this Lewis structure is not with the lowest formal charge. So then we try to think about it, whether we can form a lowest formal charge. So then we will think of move one of the bond from the oxygen to form double bond. Okay, once formed double bond, we know the formal charge for oxygen will become 0, and for the phosphorus at the same time also will become 0. So in this case, we are going to know this is the most plausible Lewis structure for the PO₄ negative because compared to previous one. So again, there is 4 oxygen here. So is it the double bond must be at the bottom here? Not necessary. Again, it can at the top here, right side, bottom, or left side here. So means that again, the position of the double bond can be changing, but even though the position is changing, the oxygen with the with the single bond still have -1 for a charge. The one with oxygen with the double bond always is 0, and the phosphorus also always 0 in this case. So formal charges are similar, but the position of double bond is different, so means that this structure able to show resonance properties. Okay, now continue with question number 9. A. Write 2 structures for the NCO negative ion and then decide the formal charge. Identify the most plausible and then explain. Basically, these questions is already discussed in the previous chapter, but since in the tutorial question is appear, so we discuss one more time. Okay, but this previous video, the question is asked us to list down all the Lewis structure, but in this case, they only ask for 2 Lewis structure. Okay, so you can just draw any 2 Lewis structure as long as fulfill the requirement. So next one again, when we want to draw the structure, we need to calculate the valence electron, total valence electron. Nitrogen 5, carbon 4, oxygen 6, negative mean gain 1 electron, so total 16 valence electron. Step number 2, in this case, as we know, nitrogen is not the least electronegative, because we already know for the most 3 electronegative, first one is fluorine, second oxygen, and then third is nitrogen. So in this case, carbon will be the central atom. Terminal atom are oxygen and nitrogen. So as usual, we are going to assign terminal atom until octet. So 2 terminal atom, each terminal atom 8 electron, total 16, so no extra electron. But then we notice that the central atom is not octet yet. So now basically we have the idea we are going to form double bond or multiple bond between the atom. So as usual, normally we are going to think of move 1 electron from each of the terminal atom, and then we are going to form double bond. So double bond in between carbon and nitrogen, double bond between carbon and oxygen. Okay. Then the next structure, as we already know from the structure here, there is negative. Okay, so among these 3 now, oxygen is the most negative. So we are going to thinking how to match oxygen with the formal charge -1. So previously again, we also already know oxygen have to be in single bond, then its formal charge will be -1. So in this case means that 2 lone pair electron from the nitrogen will going to move to form triple bond with carbon, so that the total number of valence electron still remain as 16, and then each of them have 0 lowest formal charge. Nitrogen 5 - 5 0, carbon 4 - 4 0, and then oxygen 6 - 7 -1. Okay, so in this case, don't forget the question here is asked for each atom. So here we also need to calculate the formal charge. 5 - 6 -1, 4 - 4 0, 6 minus 6, 0. So in between these two, B is the most plausible because even though both of them have lowest formal charge, 2, 0 with 1, negative 1, but your explanation is formal charge of negative 1 should be taken by more electronegative atom, in this case is oxygen. This final slide going to show you final answer for the tutorial question number 8 and also number 9. Next video we are going to discuss chapter 4.2, which is about molecular geometry and also polarity. Thank you and see you again.